What was considered unimaginable 6 months ago is now reality. Every day we learn a new concept only to find it outdated the next day. It is already old news and we moved on to the next shiny new thing. Welcome to the It Depends podcast, just as NVIDIA's GTC conference is about to start. Once again, I get an opportunity to collaborate with my good friend Rajesh Parikh, CEO of a cutting edge AI agent management system company called Synipia. He is deep into the trenches of AI. We will discuss what is hot, what is not, how to make sense of all the AI developments these days. By the time we finish this podcast, there will be a new model, a new agent, and maybe $1 trillion company. Today, we get to unpack, shake our heads at the absurdity of all these things that are happening around us. So, with that, welcome Rajesh to this episode.
Thanks, Sanjeev. Happy to be here on your podcast again.
That is great. So, Rajesh, what we are going to do is we have so many topics that we want to share. So, I am going to bring up a PowerPoint deck and we will use that to guide our discussion. Sounds good?
Yep.
All right, so let me bring this one up. Rajesh, this is we're calling this part one because when we started working on the scope of what we wanted to talk about, we realized there's so much we wanted to discuss that we didn't think we could be able to pack it into one episode. So we may have two parts of it, but we what we want to discuss is what is going on with the overall landscape of AI, and we want to look at it from the technical side, which is applications, models, agents, business adoption, what's happening in the investment VC community. How are these AI companies doing? Is a consolidation, ROI, all of those discussions. And then after we do this overall landscape, then we want to go and deep dive into models and agents. So we only have a handful of slides, but only to guide our discussion. Most of this will be a discussion. We will probably not get to compliance and some of those topics, soft topics, but we'll talk more technology today. And with that, Rajesh, over to you. Any thoughts before we put some charts to go through some very interesting stats that we've gathered, but I'll hand it over to you.
No, I think that's wonderful. I think there's so much to talk about from the last time we synced up, and a lot has moved and a lot's faster. So I think it's going to be pretty useful for everybody to catch up through this discussion of ours.
All right, so let's go to the first chart. So these are the top 22 AI revenue per employee companies, and we thought this is an interesting way to show the state of the art. So the some of this, can you see? By the way, is the font good enough for you to see? It's the size.
Yes, it is. Yeah.
All right. So where is the chart from, and what does it say?
The chart is in the public domain, and I'm sure that the numbers may have moved further from what we're seeing here. But since this is the public numbers that we can talk about, essentially there is a good amount of summary on how the AI as a platform shift is working out in the initial stages. That's one of there are many takeaways that you see, but fundamentally what has happened is we see a lot of companies with much lesser employees doing much better, as you see in this chart, which is revenue per employee. But you also can potentially judge the revenues that each of these companies are making by simply taking the multiplication of the number of employees into the revenue per employee, right? But there's also more information which talks about how and what class of companies have taken the early leads, essentially. And no surprise there. The early use cases were the code co-pilots, which have done very well, the chatbots, the conversational interfaces. We also have companies who are doing search using some sort of RAG or document search sort of technology. And now you see a lot of agents essentially pulling up into the deck in terms of the early leads, right? And in fact, the way to also look at some of these is most of these companies might look like a chatbot or a conversational interface today, but pretty much all of them would end up being agent companies as we progress further, right? So what we are seeing in a nutshell here is the agents are rising, and they're rising. And next year, if you were to talk at the same time, you would probably see a lot more clarity on where the agents are headed. And I would probably put my head out and say you're going to see a lot more agent companies on this chart next year.
So that'd be very interesting. By the way, if you look at this chart, number one is Midjourney, then down in the list is Anthropic and OpenAI. So these are three model companies.
By the way,
Number
the
two,
Adapt is no longer there. Maybe the chart is dated, but Adapt was acquired or in a way. So
I
we can
see.
skip that essentially.
So Adapt was acquired. By the way, I was going to ask you about Adapt. What is Adapt? What was it?
I think this was the one that Mustafa Suleiman ran and eventually got acquired uh,
I
by
see.
Microsoft,
Microsoft.
essentially,
I see.
right? So,
So
but it was essentially a deep research type of an agent, if I'm correct, yeah,
I see.
or a computer operator.
Number two in this list is very interesting. That's Anysphere, which is a company that creates Cursor. One of the two biggest adoptions from business side that I've seen of AI has been for coding and for CRM kind of sales agent or support, not CRM, but more like support uh, angle. So coding is being led by Cursor, Replit. I'm not sure what how Microsoft GitHub Copilot is doing these days, although
No,
it's free.
so obviously they don't publish the numbers separately, so you can't really put it here.
Yeah.
But again, this is a chart that we haven't created, so we just picked it from what's out there.
Yeah, but the good some of the takeaways I see here is if we go down this list, we see there is Harvey, which is a legal assistant,
Yeah,
and that seems to be pretty high up on the list. And then below Harvey, way down is Perplexity, which, according to the average, it's actually fallen behind. Perplexity has 202 employees. Average revenue per employee is $0.2 million. And if we multiply it, it's 202 by point 0.2, it's $40 million in revenue. What I found really interesting is that they are making 200K per employee. If we go into the data space, which is where I come from, Informatica has been such a big company in this space for decades now. Informatica actually has 300K of revenue per employee. Their
yeah,
revenue end of 2024 was $1.65 billion,
yeah,
and they have just over 5,000 employees.
yeah. No,
But
so I think these numbers are early numbers, and they may be changing every single day. These are high growth companies,
yes,
right?
but
And
that's where I
may,
was going
yeah,
because Informatica's market cap is 5 billion, Perplexity is 9 billion. Although
yeah,
Perplexity is making
yeah,
less money per revenue, but per employee, but to your point, it's all about the expanding TAM or the future growth
yeah, yeah.
of these companies.
Yeah, so I think it's too early to really make those comparisons essentially, but we're looking at a platform shift as an overall story where next 20 years, and which is what the markets look at, which is the future valuation.
Hmm.
These companies are expected to grow far more rapidly than the traditional way of looking at the SaaS and the data, essentially, right? So now you're looking at data not from the eyes of data, but really which of these companies are bundling data with an AI first approach,
Hmm.
and that's really what's driving some of the numbers. Of course, there's hype and all of that, but you're looking at the future value of an AI first approach, and that's really where the excitement lies, essentially.
Very nice. So let's go to another chart, and this one is also very interesting. Do you want to talk about this one?
Yeah, so this is essentially coming from one of the close friends who posted it a few days back, and essentially it talks about the last era, essentially, of companies that were super hyped. Let's say 2020, 2021, got really funded well, and many of them are struggling to really raise now, or haven't raised an upfront in last 3 years, right? So the peak of valuation and the excitement that we had in 2021, and the late stage essentially, and this could happen also to AI at some point if it doesn't deliver. But essentially the excitement around late stage funding may of the previous gen, uh, let's say the unicorns, may have tapered down. So it sort of presents a contrasting view of what's happening between what we call the AI first companies and the rest essentially.
So if I may break down this, so 616 unicorns
Yeah,
as of December 2021. So that's the end of the ZERP area, zero
yeah,
interest,
yeah,
uh, when money was being invested with no care for tomorrow.
yeah,
Out of those 616, 92 have exited, 524 are stuck in this state.
yeah,
Uh, of those 92, 78 were, there were just a handful of IPOs, but
yeah,
almost rest of these were just absorbed
yeah,
by other companies. 14 of them shut down. So, but in the 524, it's very interesting that 374 of them uh, are not able to raise money anymore. Actually, none of these, except for
yeah,
this 13%, they're either flat or they've done a down round.
yeah. So I think that's also a curse in a way, because you've raised at a much higher multiple,
Yeah.
and now the markets are looking at your real growth in the last 3 years. So the expectations may have settled much downward
Hmm.
compared to the multiples that these companies got at the time they were funded in 2021.
Yeah.
Right. So we've come out of the euphoria phase, and the euphoria is all backing the AI first teams at this point in time,
Hmm.
and not the traditional SaaS, as we would call it.
That is true. Yep. Okay. So let's change tracks here. Let's go to only I have two more slides. So just let's stop here. So this is the crux of what we want to discuss today. What is going on in models? Can you walk us through what's pre-training, post-training, what was hot yesterday, and what's hot today?
Yeah. So I think, I mean, if you go back just 6 months, essentially, what has really happened and continues to happen is a debate around where are we on the scaling laws, right? And obviously,
What's a
there's no
scaling
one
law?
answer.
What's a scaling
Yeah.
law?
Yeah, so I was about to come to that, but essentially, just to summarize, there's no one good answer, and there are a lot of good answers, right? But essentially, the scaling loss refers to how model performance improves with larger number of parameters, more training data, and if you were to throw more compute at it,
Hmm.
right? So it essentially infers that if you were to train with more data, more compute, then these models tend to acquire better generalization of concepts, and therefore the performance improves significantly with the model size growing, right? So in most simplistic terms, it's essentially accuracy versus the model size chart, when NVIDIA and other academic papers originally wrote about the same, right? So the deduction was that the bigger the model, the better they tend to perform. uh, and this essentially was the original scaling law, and now we can call it a pre-training scaling law,
Hmm.
essentially, right? Now what has happened over the last 6 months is starting with Ilya, who made a statement to the effect suggesting that we may have hit the end of the pre-training scaling limit, essentially. And this could be driven by data saturation, or potentially the fact that there is diminishing return for every additional unit of compute that you're throwing at the new data, right? So essentially the models weren't getting better even if they consume more data and more compute power, right? But then here's where things changed and emerged two new scaling laws. We can call them post training scaling law and the test time scaling law.
Hmm.
The idea here is essentially if you were to fine tune these models at specific tasks using techniques like RL with an environmental feedback, these models tend to generalize the concepts and continue to improve on accuracy that we're expecting them to deliver, right? So that is one of the scaling law, which is that we started uh, doing a lot more alignment at the post training phase, essentially, with a lot more quality reasoning data sets, the COT data sets,
So
and
chain
all of
of
that.
thought. So
Yeah, the COT is chain of thought, essentially,
yeah.
right? So and of course the environmental feedback, which in this case could be either RLHF driven or driven by GRPO or some other technique. I mean, there are others like RLVR and stuff like that, right? So there are these are all RL variants in one or other form, but essentially the idea is for the task that you have, you are not just training the model on the actual outcome, which is what we were doing, which is like, I mean, in technical terms, we call it input output pairs, but you're also showing it the reasons or the steps, the intermediate steps of how it can break down the problem to arrive at the final answer, right? And then you're not really, you're basically giving it rewards or some form of a reward mechanism by which you are penalizing or rewarding these models to learn better instead of showing just the answer, right? So that's really where the post training scaling came, and the model started delivering, continue to improve on the accuracy that we expect on a gamut of tasks, including maths and coding, etc. The other scaling was essentially around test time scaling, which is really about throwing extra compute during the inference. This is enabling the models to reason at the runtime, especially for very complex queries, right? So this, along with COT, significantly improved and continues to improve the model performance and reliability across task dimensions. So with these new scaling laws, right? Uh, we basically have been running even at this point in time. But what has happened since December and before December, let's say before December, we had O1, O1 preview and O1 mini, which were the earliest of the reasoning models which were announced by OpenAI. But then just around the Christmas, we had DeepSeek coming up with V3, a significantly better base instruction model. DeepSeek is a Chinese research firm, but they basically sort of brought back the energy to the open source ecosystem by releasing the model and the credible documentation around how this model design was really built, accessible under MIT, right? And
Yeah.
then they
The
followed it up yeah,
documentation is very good, right?
yeah,
The
pretty good, pretty good.
explanation. Yeah.
Yeah. And then they followed up sometime around January with another reasoning model, which was similar to O1 preview with DeepSeek R1, right? And this again was released under MIT with a pretty good documentation on how these models were trained.
Hmm.
Now, what this has done essentially to the ecosystem as a whole is it has energized smaller labs, the independent researchers to use RM as a teacher model, use the same to distill and train a student model, let's say a Llama 3.1 or 2.5, right? And try out the techniques. It could be DPOs or PPOs or even the RL, essentially, uh, to fine tune and post
Can
train these
you,
smaller models
sorry,
or what?
what
Yeah.
is DPO? What is, let's parse these things. What's DPO?
Yeah. So DPO is essentially direct performance optimization. That
Direct
essentially
performance
means that
optimization.
you're training the model on input output pairs. You're showing the model a question, you're showing the model an answer,
Hmm.
and essentially it's an algorithm which essentially basically gives the model a way to understand the answer by optimizing the loss based on whatever training data that we provide. So the distill data that you have here, let's say we've given the distill data for coding in this case, right? So you have a bunch of coding questions and a bunch of coding answers, and you use the original techniques, which is the SFT and DPO, to essentially fine tune the model for
So can
learnability,
we can
right?
we
So typically all of
just
these are
just wait, Rajesh?
minimizing loss functions.
Can we give an example? So
Yeah,
let's say it's customer service, and there is a Llama 3 model, there's DeepSeek. So how does it work? And in this customer service department,
yeah,
I have a list of, I know the
so
questions and answers I get for the last few years. So I have a Q&A set.
yeah,
I have
yeah,
an AI model, open source Llama
yeah,
3, DeepSeek. So what is teacher, what is student? I have my question,
yeah,
what would I do?
yeah. Yeah. So think about it this way. In this particular case, let's assume that you have your data available to you. So you're not going to use DeepSeek to really generate the data in this case. So you don't need a teacher model, but potentially you have a case where, let's say, you have a little data, but you want more data. Now, in that case, you could distill the data, use DeepSeek as a teacher model, distill the data, let's say additional data records,
Mhm.
and then munch to create a single data set, right? And then you use techniques for making the model train on these QA pairs. Now, the difference between SFT and DPO is essentially very minor, or let's put it
And
this way, from
SFT
a
is
layman's
what is
perspective.
SFT?
SFT is very simply a input output pair,
What does
where
it
you every
stand for?
question has an answer.
So
Every,
it's
for example, you asked
supervised.
a question.
Okay,
Yeah,
so wait, we are throwing too many topics, and SFT is supervised fine tuning, correct?
yeah, fine. Yeah.
Okay,
So
what
let's say
is,
you were to ask a question, what's the capital of France?
yeah,
And the answer would be straightforward, Paris, right?
yeah,
So here the question is, what is the capital of France? And the answer is Paris,
yeah,
essentially.
right.
But let's say if you were to go DPO, in the case of DPO, you actually show a rejected answer, and
Mhm.
you also show a preferred answer.
Hmm.
So essentially, here the question is, hey, the capital of France is Paris, which is the selected answer. But you also show that hey, the capital of Paris is not, let's say,
Capital of France.
capital of France is not, let's say, London, for
Yeah,
example,
yeah.
right? So you're basically helping model distinguish
Hmm.
between a good answer and a bad answer, and that's really the difference between the SFT and the DPO.
Hmm.
But there are many more techniques. So we can get into details, but fundamentally, the idea here is that the first one basically just gives the answer, does not tell the model why is it a good answer, right? The
Hmm.
second one shows what is a bad answer, essentially. Um, right, and there are others techniques which are emerging where you also show the intermediate steps, for example,
Hmm.
which is what we call chain of
So,
thoughts
yeah.
and various other methods,
These
right? So
reasoning models are quite amazing because they show you step by step what they're doing.
yeah,
And in
yeah,
fact,
yeah,
DeepSeek, to say a little bit about what it does, it shows way too much detail about everything it's doing. It's like
yeah,
seeing how the sausage is being made while you're
yeah,
waiting for the answer to come up.
yeah,
And yeah.
yeah. So exactly. So the what we call them as thinking tokens, essentially. So these models are also trained for how are they supposed to think, essentially. So during the trading, we provide a lot of intermediate steps. Let me go back and think. Maybe the capital of France needs to be Paris because the government offices are in Paris, for example,
Hmm.
right? So while this is not a great example of a complex query, because this is a known fact and you don't necessarily need to think about it, but just taking as an example, the reason could be because all the government offices are based in Paris, essentially, right?
Hmm.
So these models are also trained to reason, essentially, so
Hmm.
that they can generalize. So what's happening when you see those reasoning tokens, either with DeepSeek or Grok or any of them, you're basically seeing the model break the problem down, think over, essentially, and validate its own thought, and keep doing that till it is satisfied that it's answering the questions,
Hmm.
right? So just almost like how we as humans would do
Yeah,
when we just
correct.
post the questions, right? It's
Yeah.
pretty interesting to see those reasoning tokens or thinking tokens, as you would call them, when these models are actually showing them.
And the accuracy, the level of hallucination that's gone down in these models is phenomenal, right? Because now with a few billion
Yeah,
parameters, you're getting same level of accuracy
yeah,
as Llama
yeah.
3, 4, and 5 billion parameter model.
Yeah, so in fact, that is the other benefit of distillation, which we've seen, which is
So,
that because you're able to
what
yeah,
is
because
distillation?
you, yeah, go ahead.
What is distillation?
So distillation in very simple terms is essentially you have these teacher models like DeepSeek R1, which are bigger models essentially,
Hmm.
or let's say you could even say Grok is a teacher model, for example, Grok 3, right? And your student model in this case could be a Llama 3.1 or a Quen 2.5, which is a much smaller model,
Hmm.
for example, right? So what you're doing is you're basically distilling high quality question answer pairs or high quality uh, DPO data sets, whatever is that you want to do about
Within your
really learn
organization.
from these
That's
models.
your domain
Yeah,
specific Q&A.
domain specific,
Right.
right?
Right.
So let's say I'm thinking about coding or I'm thinking about
Yeah.
let's say math, right? So
Yeah.
I can distill 100,000 questions from DeepSeek.
Yeah.
Now and then basically train the student model, which are much smaller, which may not have seen all of those questions, for example.
Hmm.
And then I may use technologies like GRP or DPO, whichever makes sense, to really train these student models to learn from these examples that I'm feeding them,
Hmm.
right? So what we're seeing here is two things. One is that if, let's say, before distillation you had to do that, you had to collect 100,000 good examples, which would have been much, much more costlier to collect.
Hmm.
But with distillation, the cost of a good quality data, which is already learned by some model, and you are trying to get that and make a student model learn, has come down substantially.
Hmm.
And we're talking about very high quality data here, and hence the models, the smaller models, or what we call student models, have shown improvements to the order of 10 to 20%,
Hmm.
depending on the size of the student model itself, right? But that's significant considering that that delta we weren't able to do before these stronger models were available in the open source.
Got it. Okay. So this is model distillation is such a big topic. We are now creating these smaller models. By the way, what's a smaller model? I just put 1 billion
Yeah.
parameters to 100 billion. Would you agree? So
Yeah. So, I mean, look, there's no standard definition.
yeah.
My definition is essentially, I'm not really yet. So, these models need to have some base knowledge.
Hmm.
Otherwise, the generalization does not necessarily work. What we've seen so far,
Hmm.
and this is so far, and this could change, is that the models which are between 30 and 70 billion parameters tend to benefit a lot more, or you can extend below to 8 billion, tend to benefit a lot more from distillation than the models below them,
Hmm.
right? So if you're having a model below 8 billion parameters, that doesn't tend to give you the same level of generalization that you expect compared to a model which is, let's say, 32 billion parameters or 70 billion parameters.
So there's a reason why I
Now,
made
irrespective of all of that, all the models gain. It's only that the gain is not sufficient enough for them to replace, let's
right,
say, a larger model,
right.
essentially.
So Rajesh, I there's a reason why I took this chance of making it 1 billion. I would not, if we had recorded this last week, I would have put 30 to 70, 30
Yeah,
to 100 billion parameters. But something really interesting happened this week that we are
yeah,
recording. I saw Google had a raft of announcements, mostly Gemini, which is their large language model, multimodal. But then I also saw they have Gemma 3, which they
yeah,
launched, and it comes in three or four different ranges: 1 billion, 3 billion, up to 27 billion. That's the biggest.
yeah,
Gemma is actually a very interesting model because
yeah.
unlike
So
Gemma,
Gemma models, no, so all
it's
of the,
open source,
yeah.
first of all.
So models can be smaller size, but they are mostly, yeah, yeah,
Okay, and the other thing that I also like about, in my mind, the definition of a small model is something that can run on a single GPU. And that GPU could be in your next
Yeah.
iPhone, it could be in your personal computer, or it could be in a enterprise class server. So, but 1 to 2
Yeah.
GPUs, and you should be able to run it. So Gemma 3, by
Yeah.
the way, is
Yeah.
not a distilled model, it's a quantized model, right? And
Yeah.
so
No,
can
no,
you help?
I haven't.
Yeah,
No, so Gemma 2,
yeah.
yeah,
Can you help
I think there's a lag. There's a
quantization?
lag. Please go ahead. Yeah.
Yeah, what's quantization?
Yeah. So, no, so Gemma also could be a distilled model. We don't know. But there are two different techniques. Quantization essentially is about a model compression technique
Hmm.
where you compress a model. Let's say you have a floating point 32-bit to represent one weight. You can
Hmm.
further compress it to 16-bit or 8-bit or further down,
Hmm.
right? So the idea here is by giving away small amount of accuracy, you're shrinking the size of the model to a much smaller footprint, and you're okay with that. But for the use case you have, but you are able to run it on a much smaller or GPU or a much more cost effective hardware, essentially.
So basically, you take 32-bit weights, you make it
Yeah.
8-bit, let's say.
Yeah.
So with that, so that's quantization. So the
Yeah.
model size goes down tremendously, but you introduce a little bit of loss. And if that
Yeah.
loss is not perceptible or it's small enough, then you get a smaller model,
Yeah.
which can run locally.
Yeah,
Yes.
true. So
Yeah.
that's what most developers do. Let's say that you have your Mac with a potent GPU and your use cases, basic conversation with the search. You could potentially use some of these models.
Yeah. So you were telling me when DeepSeek came out that you could use it locally on your machine, but without a
Yeah.
GPU, it
No,
runs
no,
slow.
no. That essentially was a server machine, much more high-end machine.
I see.
Uh, but yes, you could theoretically run it on with quantization and all of that at a
Right.
much slower speed on a high-end server.
So basically, you go to Hugging Face or some other source, you
Yeah.
download, you can run it locally. If the
Yeah.
performance is not good enough, then you can then you can use
Yeah. So
APIs.
yeah. So you can use for developer setups, for example, where you save costs on testing, evaluation, all of that. But when you're actually looking at, let's say, a production environment,
Mhm.
you may use a different strategy, for example, depending on the use case, right? So you're looking at a combination of ways. So I mean, this whole conversation makes it interesting, also because there are so many choices today to really go around. What do you want to use for your developer setup? What do you want to use for your personal usage, for example?
Mm.
Right, and what do you want to use for, let's say, enterprise use cases,
Yeah.
right? So in fact, the topic that we have not covered here, but model optionality
Hmm.
is a huge topic by itself, where there is a lot of details in terms of how you even pick a model for a given use case.
Yeah. And that is really good because for a small startup that was
Absolutely.
paying hundreds of dollars for API calls a week,
Yeah.
it's now come down to cents.
Yeah. Yeah. Absolutely. Right, so that's definitely the case,
So
especially for the development workloads.
yes, and so talking about model optionality, you've talked quite a bit about one of the most critical steps in using models is the evaluation.
Yeah.
What do you mean by that? What is evaluate? What are you evaluating? How are you evaluating, and why?
Yeah, so I think the term evaluation is used in multiple places. One is agent evaluation, which we will talk subsequently.
Yeah.
But the question you're asking is model evaluation,
Hmm.
essentially,
Hmm.
right? Now, so if you actually look at the generic benchmarks, typically they evaluate the model on the basic sciences like math, physics, chemistry, coding, so on and so forth, right?
Hmm.
Uh, However, as you get to the use case, you really want these models to work for your use case. For example, And then there are other things that become important. Are these models great at function calling, for example,
Mhm.
right? Or are these models better at long instruction following,
Hmm.
right? Or are these models simply better good with, let's say, my domain specific needs, right? So those evaluations is what we call the pre-checks before picking the model. Each of these models have their strengths and a character, and depending on the use case that you have, you might find model A better than a model B,
So
and then
if
yeah,
you take an example, so it's all about examples and trying
yeah,
to so
yeah,
visualize it.
yeah.
So if I'm coding, then Anthropic Claude Sonnet 3.5 or
That's yeah,
3.7 may be a good one. Although I've
yeah,
heard 3.7 is a bit too verbose compared to 3.5, which goes
that's true.
to that scaling law limit.
Yeah, that's true.
Oh, okay, so that's for coding. But if I'm doing reasoning, then for that part of my application,
Yeah,
I'll call DeepSeek. If I want to do some translation work, then Google's Gemini,
absolutely.
in fact, even Gemma 3, by the way, I told you that 1 billion parameters supports 140 languages.
Yeah.
But if I'm doing some other pieces, I may use
For
OpenAI.
example, PDF extraction, some of the Google
PDF
models have been
extraction.
doing pretty well,
I
right?
see. Yeah.
Recently, Mistral released a model which seems to have spectacular results on the document extraction,
A document
right?
extraction. Yeah.
So yeah, so each of these models have their strengths and a
Right.
character, and when you're building a system, you probably have a combination of these needs,
Hmm.
and therefore you will use a combination of models to really build the final application that you're building.
Got it. So the last topic I have on models is open source. What is open? Like, what do we even mean by open source? Earlier on, you were saying DeepSeek published a really good research paper talking about how they trained the model, but we don't know the data set that these models were trained on.
Yeah,
And in fact, the only even Llama 3, Meta claims it's open source, but
yeah,
weights are open source, not the data set.
yeah,
IBM has a set of models called Granite. Those I
yeah.
think are truly open source because they are part of Apache license model and they open source everything, data set, weights, how it was trained. So any thoughts on open source?
Yeah. So essentially, if you look at let's say, models that we had,
Hmm.
I mean, the most lenient licenses that we have had in open source, where the users can use, modify, or change or freely commercialize, let's say,
Hmm.
were essentially Apache 2 and MIT
Hmm.
license, right? So a lot of these models have been released largely under these two.
Hmm.
Llama 3 has its own license, which is fundamentally, if you go above a certain number of active users per month, then that license kicks in. Otherwise, it's an open, quote unquote, open source model, right? And likewise others. But fundamentally, when including DeepSeek, when you look at all of these models, they are not open data slash open source models. When they
Hmm.
say open source models, they typically mean open weights, which mean, and you can use that version of the model freely, maybe fine tune it, update it, modify it, do whatever, and commercialize it.
Hmm.
Right. So to that extent, they comply to the definition of Apache 2 and MIT
Yeah.
licenses.
Yeah.
However, the real detail here is that we don't necessarily, while this is useful by itself, we don't necessarily gain the understanding of how the data itself was munched
Hmm.
uh, when these models were created. So there's a
Yeah.
lot of nuance there on how these models themselves are created, essentially, right? So there are some models where, for example, the T5, the Google's T5, which is where even the data has been open source. By the way, a lot of these models have been trained on open web data. For example, the Common Crawl, all of that. But knowing that is not enough. You want to know what was the mix of data which was finally used for the training, for example, and you also want to know the post alignment, for example,
Yeah.
right? So today, if somebody wants to reproduce, let's say, DeepSeek R1, you actually know the model weights, you know the techniques, but you don't necessarily know what was the data mixture that was fed
Hmm.
uh, to show the kind of accuracy that these models are showing, right? So, by the way, Hugging Face has a project called Open R1 where they're trying to recreate the whole R1 process by distilling data from Hugging Face, from DeepSeek R1 itself, and they've recently announced the tranche three of it, and looks like a smaller model is showing a pretty good result,
So
right?
just to explain this again, just trying to clarify.
Yeah,
So Hugging Face, Open R1, what they're doing is they're taking DeepSeek model R1. They
yeah,
have massive amount of their own data, which
yeah.
they're using their own data and retraining R1. Is that correct? Correct me if I'm wrong.
No, so that no, not. I mean, there's a little bit more to that. Essentially,
Okay.
they've distilled, let's say, 100,000 records. The numbers vary,
Hmm.
and they've taken data from other sources as well.
Hmm.
But they've taken a lot of distilled, high quality data from DeepSeek R1 itself.
Hmm.
And then what they're trying to do is they're trying to follow the training, post training pipeline that DeepSeek itself has documented in the spec, and reproduce this exact same
I see.
pipeline and the steps to create an open R1 kind of a model. So it would mimic DeepSeek on the process of creating the model itself,
Hmm.
not necessarily
Hmm.
uh, the data mixture, as you would call it.
I see. Got it. Okay. We don't hear too much about mixture of experts, but these models are all using
Oh,
MOE.
absolutely, absolutely. So
Okay.
MOE is most of these models are MOE today.
Yeah, which is so interesting because MOE was such a big thing 1 year ago, and now it's just taken.
It is. It is. It
It's
is.
like
It is still the
hidden.
same. Yeah.
Yeah. Okay. So we've talked. By the way, before we end the section and move to agents, I just thought we've talked about all the big. So we haven't talked about AWS because AWS has a new line of models.
Yeah.
Microsoft is also making their own models now, like
Yeah.
5.4, for instance,
Yeah.
is PHI 4, 5, I think it's pronounced 5.4,
Yeah.
is the
Yeah.
latest model.
Yeah. Yeah.
And we haven't talked about hardware at all. So
Yeah.
NVIDIA got hit pretty badly when DeepSeek came out because the idea was that we are going to do more inference time computing rather than pre-training. So why do you need so many GPUs? Although with this whole idea of G1's law, when things get more efficient and cheaper, the usage goes up.
Yeah.
And so there will always be more use of GPUs.
Yeah.
So NVIDIA's CEO basically that was his statement.
Yeah, that's true. No, so absolutely. So like we said, the DeepSeek R1 was a big moment for the open source,
Hmm.
and it has certainly uh, accelerated as well as improved the understanding of what goes in the post training of the models itself, right?
Hmm.
Which is earlier sort of very close knowledge with the top tier foundation model companies,
Yeah.
essentially, right? So there's definitely new energy
Hmm.
in the ecosystem because of democratization. The smaller models have certainly started looking a lot better than they were a few
Yeah.
months ago,
Yeah.
right? So all of this is really going to increase the consumption, and beyond that, we also talked about the two new kinds of scaling, essentially, which is the scaling at the post training level, the scaling at the inference time, and all of this needs GPU at the end of the day, or let's say compute,
Yeah.
right? So in that sense, I wouldn't really worry about it. In fact, I would say that this is actually a positive because more people are trying now
Correct.
to build models than a few
Yeah.
labs, right?
Yeah.
So automatically the adoption accelerates, the consumption accelerates, and that's good for everybody at the end of it.
Yeah. So before we end this section, so I just want to say NVIDIA is, of course, the king in the space of GPUs, but there are other companies that are starting to make very
Yeah,
strong moves. Cerebras is one of them. I know at
yeah,
least two senior executives from different companies that have actually left their companies and moved to Cerebras. in terms of training models. So OpenAI was all in on Azure, as we know, and then they started using Oracle Cloud Infrastructure (OCI) data center to train. Still NVIDIA chips. Now Stargate projects being launched by the US government. So there are more players. SoftBank from Japan is now in the
Yeah.
picture. And then I just saw recently that OpenAI also signed some 11, $12 billion deal with CoreWeave. And CoreWeave is a specialized data center for GPUs only, mostly
Yeah.
NVIDIA actually. And so now they're going to use CoreWeave to train their models.
Yeah.
And CoreWeave may
Yeah.
actually go
So there are.
IPO this
Yeah.
year at about weights and biases. Go ahead.
Yeah. I was saying that even Satya mentioned that there are more players and there's going to be abundance of compute that's hitting the ground, and even Microsoft wouldn't mind leasing them instead of putting the
Yeah,
capital investment
right.
upfront, right? So, and this along with obviously the sovereign AI, which is towards the eastward in countries like India, the Middle East, all of that, investing in their own compute infrastructure, right? So yeah, so computer is growing by leaps and
Yeah,
bounds, and you and I have spoken about it earlier that by 2030 it's pretty likely that the accelerated computing is going to cross the traditional computing by a big margin.
correct. Even
uh,
Meta may have their own chip this year, their
yeah.
own AI chip. All right,
Yeah.
so let's move to agents.
Yeah.
So we were discussing what exactly is a Gen AI application. There are so many different options here. LLM wrapper. Where does the business logic exist? RAG. What are your thoughts? What's a Gen AI application?
Yeah, and you know what? This is a pretty interesting question, and depending on who you ask, the chances are you will probably hear a common answer which has been floating around, right? So, based on the design patterns that we see in open source or OSS agent frameworks, essentially, right? But largely, the way these frameworks look today, it would make you feel that every agent is like a single task with a few set of with an LLM embedding or let's say LLM inference API integrated and a few set of tools, essentially.
Mhm.
But in my mind, this does not even fit the basic smell test for what an agent should be, right? But
Hmm.
this obviously is great to start with, but this is not something that would I would call an LLM application, right? How can we really say this, right? So the idea here is that even in the traditional software engineering, we have seen multiple design patterns essentially. If you come down to traditional software and data engineering,
Hmm.
right? So, for example, products like Fivetran or Zapier, these are often a few step workflows. Think
Hmm.
of them as connected services in the traditional worlds. And what they would do is they will basically connect the applications, extract data, and load it into the destination,
Hmm.
essentially, right? And
Right.
hand it off to the next application to do the larger task.
Hmm.
Now, I would call them as synonymous to the L1 agents or the frameworks that we see today, which are really lightweight,
Hmm.
essentially. Here, the assumption is that all the heavy lifting would be done by the model itself. For example, the reasoning, the task breakdown, all of that, right? So your reasoning is dynamic. The agent is simply connecting the tools and the models together with the user query, essentially, right? So, however, in real world applications where you need a lot more guarantees, then you cannot necessarily depend on all the reasoning that the models embed. For example, there are cases where you already know the workflow prior. Let's assume that this is a customer support use case. You exactly know how the customer support process looks like, and you want the model to follow exactly the same process and not deviate from it.
Hmm.
Now this would look like a DAG in the traditional data engineering workflows, right? Or a feature engineering workflow, or like an application with a fast API or a Django,
Sure.
right? Now we can call this an L2 agent, which is the agents not just have used the LLMs and the tools, but they also have a more well-defined, let's say, a DAG or a process workflow on how these agents should respond to various queries, essentially from the user. Right now, this is where the reasoning is maybe induced into the model from the human workflow, or maybe stated out of bound, where each of the nodes in this DAG is an LLM node, essentially, right? And then there is L3, which is what I call the multi-agent systems, essentially. So in the second case, you're not just looking at a single task, but you're looking at probably end-to-end process, which a single agent would cater to, right? And then there's L3, which is the multi-agent systems. Here, they might look similar to a set of microservices that we've seen in the past in the traditional software engineering, where each agent is part of a larger complex query or a process, does its part of the process in a large multi-agent deployment, essentially. And this could have tens or hundreds of agents within it to complete the task or the goal that we have, right? I mean, I'm just, if I were to take an example, think about, let's say we're trying to make a software engineering team, for example. Now you could have a product manager agent, and the sole task of the product manager agent is to write a good user story given the user requirement,
Hmm.
right? And then you could have a project manager agent who takes this user queries, breaks down into a proper project plan, splits it into the subtask, and then assigns them to, let's say, a software engineer agent, for example,
Hmm.
right? So that's really where I think we're looking at a multi-agent system, which can cover a fairly large complex requirement, which starts with a, let's say, a business requirement to user story to actually implementing and deploying the whole project, essentially.
So, if I were to take it to the next point, the one of the hottest topics these days is Anthropic's MCP, Model Context Protocol.
Yeah,
And I think there needs to be some clarification on what exactly is Model Context Protocol. What does it do? Because people are starting to think, oh, this is like agents are talking to each other using an
yeah,
MCP, but it's not. MCP,
yeah,
so I'll take your example. When the product management agent says that I need to write a user story based on user requirement, but I need to put it into Jira. So
yeah,
that connection between the model that is going to generate the Jira ticket, let's say, and write it into Jira, that communication is getting standardized through Anthropic's MCP. So MCP is actually the point number two under interoperability. It is an agent to tool or agent to data source. So, an
yeah,
example of MCP could be if I have a personal agent that reads my email, what if I have multiple emails? I have Outlook, I have Google, Gmail, I have some other ones, and I wanted to update my calendar. And then I want the model to also create a plan and says, oh, because I've not only updated your calendar, but I've also gone and changed your reservation on United Airlines or Emirates. So that communication between the model and the outside world is what MCP does.
yeah.
So correct me,
No, no,
please.
I think you're absolutely right. But there are many other. Let's put it this way: the communication was always there in the form of REST and other things.
Mhm,
What MCP really does is standardizes the interface
mhm,
to a new tool, essentially,
mhm,
via a client-server architecture where the transport could be anything. For example, currently it's a standard STDIO or a basic socket, for example,
mhm,
right? But the transport layer can be any of your technologies that you have. But what they've done is they've used a set of JSON RPC messages to standardize what goes on top of this transport, for example, right? So how would you access a resource, for example? There is a message protocol for that. How would you access, let's say, a tool or a function? there is a most message protocol for that. So what it really tried to do is decouple the model or the application
Yeah.
side from the actual tool,
Yeah.
essentially via a proxy architecture in a way,
Yeah.
right? A good use case for this is, for example, computer use, which is where this tool first came in, which is, let's say you're using Anthropic's conversational interface and you wanted to access the file system on your laptop, for example, or let's say the code file is lying on your laptop. Now, that's a good use case where you run an MCP proxy on your local laptop, and you configure the Anthropic to actually point to that particular proxy, and it's then able to access the files locally, which are local to your laptop, essentially.
Got it. All right. So that computer use API was quite an interesting
Yeah,
thing that came out, OpenAI operator. So
yeah,
I want to make 2 points before we move on to next topic. So, but I want to come back to this, but I just want to mention that there's agent to tools, data sources, which is Anthropic's MCP, but then agent to agent
yeah,
communication is also in the works. For example,
yeah,
I saw just this week, AWS went GA with the agent collaboration, which is
yeah.
their agent to agent communication protocol. The,
Absolutely.
yeah,
So in
go ahead.
fact, before that, a few weeks back, we saw OpenAI coming up with a swarm architecture, so on and so forth,
Hmm.
right? So everybody has been announcing their version of multi-agent.
Hmm.
However, these are not the same in a sense that these are still fragmented, haven't found the same amount of traction as MCP
Yeah,
by itself.
yeah.
I mean, just to be clear, MCP is also not an agreed standard, right?
Yes,
Although it has more community traction,
correct.
essentially,
I
right?
was
Uh,
I was
yeah, but
at Gartner
yeah,
Data and Analytics Summit last week in Orlando, and I was surprised even data catalog company Alation announced support for MCP.
yeah,
So it's
yeah,
getting more
yeah. So MCP is becoming like the new, let's call it open AI spec,
yeah,
where the tools interfaces are getting standardized.
yeah,
So, for example, in this case, Alation would want its APIs to be invoked from, let's say, via MCP proxy that they've built by Anthropic, for example,
yeah, yeah.
right? So it from a tool vendor point of view, or it basically helps them encourage adoption of usage of their tool, consumption of their tool, essentially.
Very nice. And the other thing I also wanted to mention, going back to the computer use API operator. So the big thing that happened also recently was yet another Chinese company came in.
Yeah,
They were being called yet another watershed moment. It's called Manus. And Manus is not a model company like DeepSeek is. It is an agent company. And what they did was they basically made it very easy by packaging a lot of these agent capabilities like computer use, operator, code compiler, all of
yeah,
that into a single, very easy to use
yeah.
package. And so actually, Manus has already seen somebody has forked it and made it open source, and it is called, pardon my language, Inus, not Manus. So,
Yeah, no, absolutely. So, I mean, there's been a lot of how do I say, anything that that essentially goes viral. We start seeing the open source version of it. We saw
right.
Open R1, and now we're seeing Open
Yeah,
Manus, uh, as they call it. Having said all of that, I think Manus is a good example of what can a generalized agent do,
yeah,
or how powerful can they get,
yeah,
assuming the models are powerful and agents are built the right way. In which case, in the case of Manus, it has integrated a lot of UI components to make the agent feel a lot more seamless. Of course, the component seems strong. Obviously, we don't know the detail whether it's coming from Anthropic, which is the model they use, or they're also claiming they have some private fine-tuned models.
hmm,
Uh, uh, but that detail needs to be seen. But fundamentally, it depicts a very, very strong planning model essentially
So
under
to
the hood.
build these agents, we talked about in a document we did on trends for 2025, rise of a category called agent management systems.
Yeah,
And there's already agent frameworks like Crew.ai is very well known. There are dozens and dozens of agent
yeah,
management, agent frameworks. And now
yeah.
there's agent management system. What does an agent management system do, and how is it different from an agent framework?
Now it's something that we absolutely called out much before others, and I do believe when I was looking at one of the recent presentations from Sierra, they call it agent experience manager
Hmm.
management. But fundamentally, these are terms essentially used for streamlining the life cycle management of the agent itself, essentially. Now, the agent framework per se basically helps you build the agent, but it does not help you evaluate these agents, for example, or it does not help you deploy or orchestrate these agents in production. It
And
does not help
monitor.
you govern, version manage, all of that, right?
Hmm.
Now, for any serious agents to be deployed, you need all of these components that you need. And today, what happens is you end up picking each of these components separately. You need a monitoring component, you need a troubleshooting and debugging component, you need an orchestration component, you need governance, you need the data layer, the model connectivity, all of that, right? So what an agent management system does is brings all of these pieces together seamlessly, so
Mhm.
that if you're an agent developer, you can fast iterate from the concept all the way to productionizing these agents essentially. And of course, if you're going to the next version and let's say you're changing the prompt, because you've automated these evals and automated testing, in the middle, it actually makes you recycle the new prompt much faster than you would
Hmm.
have done otherwise,
That's
right? So there
yeah.
are a lot of interesting outcomes because you have an agent management system, and one of the key one is essentially reducing the cost of build out of the agent itself, and thereby reducing the failure of many of these projects.
Hmm.
Uh,
That's the
Today, the failure
important
rate
point.
of agents in real world is much higher.
That is great. So let's wrap it up with
Yeah,
two interesting topics. Where is the ROI in all of this? Microsoft and Salesforce seem to be going at each other, uh, and there's, for example, Microsoft thinks or Satya Nadella thinks that uh, the end of ERP is coming. It'll be agents, and Salesforce calls Microsoft agent a Clippy. And then we have OpenAI, which is ready to charge $20,000 a month for its services. So, your final thoughts before we wrap this up for today?
yeah. No, so I think let me start with the $20,000 one, $20,000 per month question. Obviously, they're talking about a research agent, a high age agent, which could replace a PhD scholar
Hmm.
uh, at research or cutting edge research work, right?
Hmm.
Um, to be able to charge that. Now, well, that could be $1 billion, if not $1 trillion question. If, whether we could have agents which you can charge 20K a month, and is generalized and will not get copied, right? So the way I think about it is, yes, in time we will have a 20K or a 100K agent. That's just a number, and it's possible. uh, it's a question of how much of the value that these agents provide is nuanced and is not easily copyable in a few months from the announcement that OpenAI does, right? The answer to that is really how nuanced are these agents in terms of their implementation, right? In my mind, if you're building a general purpose agent with web search, summarization, even if it's a 20K research task, it will essentially eventually get copied. Let's assume that the agent is going through all the papers, doing cool work of reading, summarizing, hypothesizing, all of that, right? But given the generalized nature, you would see that people will build the same thing at much cheaper value,
Hmm.
right? So it will eventually boil down to what was the quality of what you built and how nuanced was it
Yeah.
for these prices to hold. Now that's the first part. On the question of the ERP, uh, Whether the ERPs will get replaced by the agent, the way I want to think about this is that the UI, the ERP has two pieces. One is, of course, the workflow and the database, and the second is the UI of the ERP itself. Right now, with time, if agents are the primary user of ERP, right, the ERPs would then start looking like a set of database tables and a
Mm.
set of domain workflows, essentially under the hood, right, which can then be exposed to these agents as tools or skills that the agent can work with, right? But obviously, that's much easier said than done. The ERPs today are a far more complex systems which
Oh,
span
yeah.
across multiple departments,
Yeah.
multiple processes, many processes, and a chain of tasks within those processes,
Yeah.
right? So theoretically, if we did build a multi-agent system, you can achieve the operational layer on top of these ERP models and data tables, and therefore get into the realm of turning an ERP into a, let's say, a multi-agent system,
Mm.
right? However, we are talking about climbing up the complexity much more rapidly than where we are today,
Mm.
essentially, right? So what is really required here is we need to start seeing successes with, let's say, taking a piece of ERP and building a multi-agent system around it, and see that this agent system can operate that particular process pretty well and the
Mm.
set of functions pretty well independently. Now, once you've crossed that bar and you see that working, then conquering the same process by process, making it better over time, is just the additional work that you need to do from there on. And of course, at that point, what Satya is saying could really be true.
Hmm. Amazing. Well, we'll see. So much is happening. With that, I think we've briefed quite a bit. So I think we could end here till next time.
Yeah,
And thank you so
yeah,
much for taking time and discussing all of these interesting developments. So,
yeah. Thanks,
welcome.
Sanjeev.
Thanks, everyone. Until next time. See you. Bye.